Welcome to part 1 of limits at infinity. In this video I'm going to show you the basic technique for solving limits at infinity, and then one example of how to apply this technique. First of all, what are limits at infinity? Well, limits at infinity are just like normal limits, with the only difference that x is approaching infinity instead of a number. The notation we use is the same. Here, instead of a number, now we have infinity, and this is read the limit as x approaches infinity of f of x. What do we mean when we say x approaches infinity? This sounds very mysterious, but what we mean is just that x is ground without bounds. And another way to think about this is to say that x is taking values greater than any number you can come up with. Now I want to talk about how to solve these limits. And the neat thing is there is a single technique you can apply to every limit, and to almost any limit at infinity. And we will go step by step to learn this technique. And step 1 is to find the greatest exponent in the function. For example, let's say that we want to find the limit of this function here. Well, the first thing we need to do is to look at the exponents of x. Here we have x squared, that's an exponent 2. Here we have exponent 0, here we have exponent 2, and here we have exponent 1. So in this case, the greatest exponent is 2. Step 2 is to divide the numerator and denominator by x to the n. Here n is just the greatest exponent we just found, and in our case n equals 2. So we divide everything by x cubed. Remember that you can do this with fractions, because here the x squared cancel out and you remain with the same expression again. Step 3 is to simplify the expression. Here, for example, what we can do is to separate the terms. Here we can take 2x squared over here, the minus 1 over here, and do something similar below here. And next we can cancel out some things, cancel the x squared, cancel the x here, and that's the final expression. And the last step is to calculate the limit directly. I will show you how to do that with this example. So let's say we want to find this limit, the limit as x approaches infinity of this function. Step 1 is to find the greatest exponent. In this case we have x cubed here, so the greatest exponent is 3. Step 2 is to divide everything by x cubed. If we do that, we get this expression. I just divided every term by x cubed. Next, we can cancel out some things like this x cubed here, the x squared here, the x cubed here. So we get this expression for our limit. And the final step is to calculate the limit directly. Now, this limit has a form that can be calculated directly. That is because these terms will all go to 0. We just need to assert that anything that is divided by x will go to 0. For example, this term will go to 0 because x is approaching infinity. To understand this, you can try this in your calculator. Pick any number, for example number 2, and divide it by a very big number. You'll see that you get very close to 0. And that will work for any number in the numerator. So using the fact we have that this term goes to 0, and this term is also divided by x, and when x approaches infinity, x cubed will also approach infinity, so this term will also go to 0, and by the same reason this term will also go to 0. So we're left with this little limit here. Here we have the limit of a constant, and the limit of a constant, even when x approaches infinity, is the same constant. and that's the final answer. That's all for now. Thank you for watching and see you next time.